Hello and welcome to Unit 4 on Conservation of Energy. This video is the start of Lesson 3 on Gravitational Potential Energy. So in this video we will be discussing example question number 1. But before we get going on that, a short little note on what gravitational potential energy is. I think many people coming from something prior to this, like Science 10, probably have a little bit of a grasp on what this is. And really, gravitational potential energy is just how much energy an object has based on how high above the ground it is. So you could imagine that if you have an object being held up over your head, if you release it, its potential energy is going to convert to kinetic energy and smash it into the ground. Whereas if you had an object that you were holding just a few centimeters off of the ground, it won't accelerate very much, and it probably won't smash when it hits the ground, because it only has a small amount of potential energy to convert into kinetic to, smash. Or not. With that said, our formula for potential energy is fairly straightforward. We have energy, which is potential due to gravity, so EPG is sort of the standard notation I use. And it is equal to the mass of the object times little g, or the acceleration due to gravity on Earth, times however high that object is. So mgh. Alright, and again, the units for this energy are in joules. Okay, let's get going on this first example then. We have a 350 gram object initially at a height of 64 centimeters. So I actually didn't draw this one out before I started, but we can quickly sketch this here. We have our object. It is 0.35 kilos, and it is at a height of, there we go, I'm using all the same color, but whatever, a height of 64 centimeters. So 0.64 meters. Alright, but it gains some energy. We see in our formula here, height is on this side, energy is on this side. If height increases, our energy value is also going to increase. So if our energy is increasing, we're talking about potential energy, something based on this position, we know that we are also going to raise the height of this object. So somewhere in here, this object is going up. And the question is just asking, well, it's asking the final height. So it's going to ask this height plus the new height. So how do we go about solving that? Well, really all we have to do is figure out how much height that amount of energy given correlates to. So let's write a formula out here. Energy potential due to gravity is equal to mass times gravity times height. And if we isolate for height, we can say height is equal to EPG divided by mass times gravity. Plug some numbers in here. It said we are increasing by 800, actually this is 800 millijoules, so that's something we should keep in mind. This is plus 800 millijoules. Millijoule is less than 1 joule. It's not megajoules. This is actually 0, well, it looks like a backward 6, 0.8 joules is how much this is increasing. Divided by the mass, 0.35 kilos, and we've got little g down here too, so 9.81 meters per second squared. Alright, this is leading close to the final answer. The height that this gives is 23.3 centimeters, or 0.233 meters. So we want the final height, because this is just how much this raised above the 0.64 meters. So final height is going to equal 0.64 meters plus 0.233 meters. We do have 3 sig digs, I believe, in this question. Yes, just to double check. So our final height works out to 87.3 centimeters or 0.873 meters. I'll also put the centimeters on here as well. There we go. Our new height based on adding a little bit of energy to this object. Okay, that's all for example 1.